Okay, we're going to talk about proportions. And you might remember this stuff, proportions, from algebra, because you ended up doing some of this in algebra. And the basics to proportions is when we have a fraction like 3/4, and it's equal to something over 20. Now you're like, oh, wait a minute, this is kind of like when we had to have common denominators to add or subtract fractions. Yes, it's exactly like that. So it's like over 20, and we want to know what that top number is. Now most of you can do this one in your head, but when they get to be more complicated, you won't be able to. So I'm going to draw an arrow from the denominator on this side to the numerator on this side, and an arrow going up this way. The arrows always point upward. Now, the reason why I'm drawing these arrows is to actually tell me where to put the answers when I multiply. So 3 times 20 is going to go over here on your left, and 4 times x equals 4x. And the equal sign stays right where it is. At the moment, it doesn't make that big of a difference which side we put it on. It will later on when we do some things with inequalities and stuff like that. So we're just going to get into the habit of doing it right now. So let's finish solving this one. We divide by 4 and we divide by 4, and x equals 15. So this needs to be 15. So 3/4 is actually equal to 15/20. Don't be surprised if you get fractions. It's not a big problem. You probably get lots of them. Now, the place where this comes into play with geometry is when we're dealing with similar triangles. Now, these will also be called proportional triangles. So I'm drawing two similar triangles. That means that they're the exact same shape, just different sizes. And so if I come over here and I said, all right, let's see, this side's going to be, let's make it a 6 and an 8 and a 10. And then this side here is going to be half as much. So it's going to be 3, 4, and 5. And so this is the basics for similar triangles. Now, there's no real problem on this one because we know all the sides. And we can look at them and go, yep, this one right here, this is twice as much as this one's twice as much as this one's twice as much as this one. So yes, these would be similar. But sometimes you don't know necessarily what one of the sides is. And so we end up with something like this. And you can't just look at it and say, oh, this one here looks about twice as big as this one. No, it doesn't work that way. Instead, we can say, all right, that one's 7, and maybe this one's 4. And maybe this side is 12, and we want to know what this side is. So we have to set up our equation. So our equation, when we do it, it's going to have a fraction on this side, it's going to have a fraction on this side with an equal sign in between. Now, I want all the information from one of the triangles on top and all the information from the other triangle on the bottom, the numerator denominator. I don't want to mix them up. I don't want to get this x on maybe the top and the 4 on the bottom. I can, if I do it right, still do that, but I really want you to keep it straight, so I want it on both on top or both of them on bottom. So to start it off, I'm going to put the 4 on top, and so that means I'm going to put the x on top. And then over here, I need to go to the corresponding side. So this side and this side are in the same location on the triangle, so they are corresponding. So since the 4 is on top here, the corresponding side has to be on the bottom. So 4/7. And since the x is in this spot, I need the corresponding number, which would be 12. And then we're going to solve. we're going to go, okay, draw our little arrows. And 12 times 4 is 48 equals 7 times x is 7x. And divide by 7 and divide by 7. Aha! Fraction. 48 sevenths. X equals 6 and 6 sevenths. Don't sigh. I know you guys are thinking, oh, fractions. Don't be haters. Fractions are numbers too. Alright, so there's our answer. Okay, now this can actually look a whole bunch of different ways in order for us to solve these things. But for right now, almost all of them are going to be based off the whole idea of corresponding sides. One of the tougher parts will actually be to figure out which side is corresponding to another side. I'm going to do one more example here. And let's say in this case I have a rectangle. And I have another rectangle, even though we'll mostly be dealing with triangles in this section. And somebody says, oh, this side is 24. And I don't know how long this side is. But I know it's similar to this triangle. And this side triangle here has a side of 10 on here. And on this side over here, it has a length of 3. So again, I'm going to try to keep all of the information from one of the shapes on either the top or bottom. So fraction, fraction with an equal sign in between. So I'm going to put my x and my 24. And let's see, my x is on the short side, so the corresponding side is over here with the 3. And the 24 is on the longer side. The corresponding side would be 10. And then, ta-da, cross multiply. And we get a 30x equals 72. Divide both sides by 30. 30, not 3. And x equals, let's see, that would be 2 and 12/30ths, otherwise known as 6/15ths. Otherwise known as 2/5. I'm just trying to reduce this down. So let me see. 2 and 12/30ths. If I divide this one by 6 and this one by 6, I get 2/5. So 2 and 2/5. That was just reducing. That's all I was doing there. Okay? And if you put it into the calculator, you get 2.4. All right. But we're going to keep them in fraction form as much as we can. So that's the basics to proportions. Make sure you understand that we can have proportions in almost anything we want. We're going to be using them in lots of different ways. And it's going to be set up because we have similar shapes. Make sure you understand that. All right. We'll see you in class.